All right, let's dive right into this explainer on how to actually visualize and map complex business ecosystems. We're talking about making that crucial leap from a linear economy to a circular one. Look, if we want to move away from the old take, make, dispose model that's just draining our planet's resources, we've got to fundamentally shift how we see the world. We have to stop thinking in straight lines and start thinking in interconnected systems. But how do you actually do that? How do you look at a messy, super complicated supply chain and figure out how to make it circular? Well, the answer seems to lie in a concept called ecosystem mapping, and we're going to unpack exactly how it works today. Here's a quick look at our roadmap. We'll cover what ecosystem mapping is, how to visualize nodes and interconnections, compare 3 different mapping tools, and then dive into the holistic diagnosis approach, specifically applying HD1 and HD2. So, part 1. What exactly is ecosystem mapping?
Well, systems theory tells us you can't just isolate one part of a business and expect to understand the whole thing, right? You really have to zoom out. And when you do, the very first step in mapping an ecosystem is identifying what we call nodes. Think of these as the individual players in your network. A node is basically any principal component that makes up your system. If you're mapping an industrial ecosystem, a node might be a local supplier, maybe a massive manufacturing firm, an energy distributor, or even the end consumers themselves. You literally can't map a network until you know exactly who's playing on the field.
But, it's not enough to just list those nodes. The real lifeblood of any ecosystem lies in its interconnections. These define the actual living relationships between the players. Are they exchanging physical raw materials? Are they sharing a water source? Is there a critical transfer of specialized knowledge, digital data, or financial capital? By mapping out these connections, we start to see exactly how all these separate entities rely on one another just to survive and function in the broader environment. And the core reason we do all this is simple. It's to tackle that crazy complexity right at the very beginning of our research. You simply cannot fix hidden waste or discover cool new circular opportunities without seeing the whole picture first. Because mapping is fundamentally a problem-solving tool. It lets us step back, collect a massive amount of messy, interconnected data, and synthesize it into something actually understandable. Once those invisible relationships finally become visible, that's when you can step in and design a totally new, way more sustainable solution. Moving on to part 2, comparing 3 mapping tools. When you start mapping, you'll find that tools exist on a pretty broad spectrum of complexity. On one end, you've got simple Canvas templates. These are incredibly beginner-friendly frameworks with predefined categories where you just list your actors. Suppliers go here, customers go there. They're fantastic for an initial brainstorm, but they usually miss the big picture because they don't capture the actual lines of interaction. Contrast that with Giga-maps. These are highly detailed, often massive visual diagrams designed to capture the true complexity of all those intricate relationships. They really showcase the wonderfully messy reality of a functioning network. Evaluating these methods reveals a really clear trade-off. Canvases are fast and easy, but that crucial relationship mapping is entirely missing. Giga-maps completely capture those relationships, sure, but they are super difficult to create and require a massive time investment. But there is a third option. It's called holistic diagnosis. It sits right there in the middle. A medium to difficult level, and it does take a high time investment, but it gives you a highly structured, perfectly complete picture of both your internal industrial flows and your external environment. Which brings us to part 3, the holistic diagnosis approach. Derived directly from the systemic design discipline, holistic diagnosis is specifically tailored to analyze human-made industrial processes and basically help transition them toward a circular economy model. It uses what's called the ARC-VI structured process to tackle these networks. And it's a bit of a journey. You start by assessing, figuring out the scope and boundaries of the problem. Then you research, mixing desk research with deep, in-the-field observations. Next, you collect and synthesize all that raw data into a structured database. Step 4 is visualize, bringing the data to life by drafting out the actual maps. And finally, interpret. That's where you analyze your complex map to design future solutions and find those hidden circular opportunities. Let's jump into part 4 and actually see this in action by applying HD1 and HD2. Holistic diagnosis splits mapping into 2 distinct phases. HD1 focuses entirely on internal energy and matter. To see this in practice, let's track the inputs of an agricultural processing system. Imagine tracing raw materials, let's say harvested hazelnuts, arriving from local farms. These inputs literally cross the open boundaries of our system. But it's not just the nuts. A good map meticulously captures the water, the electricity, and even the human labor entering the system at that exact point in time. Once inside, those raw inputs enter the actual sub-processes of production. Think about the shelling plant. Energy is consumed and matter is completely transformed. Heavy machinery uses electricity to crack those hard shells, while fresh water is probably being used for washing and sorting. By meticulously tracking these internal flows, we start to deeply understand the industrial metabolism of the facility itself. We see exactly how it breathes and consumes resources just to function. Now, the absolutely crucial realization here is that we aren't just mapping the final product, we are pinpointing exactly where waste is generated. Yes, the process yields edible hazelnuts as the primary output, but a linear economy just stops right there. By using the HD1 methodology, we conceptually isolate all the byproducts and emissions. We're talking thousands of pounds of leftover hazelnut shells, gallons of wastewater, thermal heat exhaust. In a traditional system, these are just treated as expensive disposal costs. But here is where the magic happens. The ultimate goal of the HD1 map is to connect that waste directly to an external actor who can transform it into a brand new product, successfully closing the loop. By stepping back and seeing those shells mapped out visually, you can ask, wait, who needs this resource? Suddenly, those waste shells can be sold to a local biomass energy plant, or maybe compressed into eco-friendly building materials. What was once a costly disposal problem becomes a brand new revenue stream. It brilliantly mimics the way a natural ecosystem recycles absolutely everything. Now, while HD1 zeroes in on the internal industrial metabolism of a specific plant, HD2 is completely different. It zooms out entirely to examine the external context, the actual environment where this facility is located. Because you simply cannot design a truly sustainable circular system in a vacuum. A brilliantly mapped recycling solution that works perfectly in a bustling, highly connected European city might completely fail if you just transplant it directly into a rural, isolated agricultural region. By investigating these HD2 demographic and economic features, we ensure that any new circular business model inherently fits the specific characteristics and limitations of the local territory. We map the physical terrain, the local population density, the traditional industrial activities of the broader region, even the local folklore and culture. Think about it. If we want our hazelnut shell recycling program to actually succeed, we absolutely need to know if there are robust local transport networks to move the shells, and if the local workforce has the cultural background and technical skills to actually process them. Ultimately, ecosystem mapping teaches us a pretty profound lesson. In nature, there is no such thing as waste. The output of one process is literally always the input for another. By combining the internal energy flows of HD1 with the vital external context of HD2, we gain kind of a superpower, the ability to see the invisible network sustaining our businesses. So, thinking about your own network, what invisible connections or wasted resources would you uncover if you applied this ecosystem mapping method to your own business tomorrow? Grab a pen, start drawing out your nodes, and find out.